good morning. Welcome to the first session of the third day of the conference. I'm really happy to see such turnout because it's not fun to wake up when you have to be somewhere at 9 a.m. But I hope the topic of today triggered your attention, which is Ethereum fundamentals. So let's get started. First things first, this is the first time in the history of mankind when we are able to permanently record the history of mankind. Think of how disruptive this is. Of course, blockchain is a bubble and it's going to burst at some point. I think it bursted like this week. But that's amazing. It's a very natural cycle for any economy to crash, and then only genuine blockchain projects will survive. And the topic of today, Ethereum, could be the one of them. This is a project of a solid size and a solid community, which might be able to survive all the crises. So a bit about me. My name is Jana Petkanic. I studied applied mathematics many years ago. I then worked as IT services manager because I decided I don't want to spend my life stick to computer doing the stuff. But I shifted to IT consultancy, IT services at Accenture and Henkel. I ran an NGO to fight the food waste. And currently I'm based in Amsterdam and I'm a blockchain consultant. I'm very focused on token economy models, and also I'm running monthly events in Amsterdam called Blockchain Talks. So what can you expect today is you will understand what blockchain is. We'll have a look at the main features of Ethereum. We'll have a look at the beauty of Merkle trees, and you will learn more about some interesting use cases around blockchain. And of course, we will learn how can we potentially improve an industry which creates 2/3 of global GDP. Think now what kind of industry I'm talking about. And perhaps what I hope for, you'll find a new meaningful passion because we are missing people in this industry. Still, blockchain community is very small in comparison to the internet one or a standard developer one. Okay, so let's have a look what makes blockchain so interesting and what is its utility. Let's have a look at the value transfer today. So basically, any supply chain consists of 3 levels of flows. First one, information flow. Next one, money flow. And the third one, product flow. So this summed up, it's supply chain. Financial sector is nothing else than information flow and money flow combined. Okay, so I won't go into detail because everyone, you are familiar how does bank transfer look like, but let's have a look at what blockchain can change in the value transfer. So I have bank A and I want to transfer someone money to bank B. So I place an inquiry with my bank, which sends information across the internet to the bank B to rewrite the ledger, basically. So entire value flow stays with the bank, and we trust the bank that they maintain ledger accordingly, so we prevent double spend and other issues which might happen in inaccurate value flow. But what if we can do things differently? And what if we can do the transfer value differently? Let's have a look at the value transfer of tomorrow, which is actually possible even now with cryptocurrencies. And this is a use case which can be very useful for 2 billion people in the world. I will explain later why. So imagine I want to send someone some value across the internet, but the value with liquidity. It means that when a recipient receives something what I sent to him, some digital asset, he is able to find a buyer and to cash it out into fiat currency. So basically what can happen with blockchain is, yes, pretty much like with a bank, I place an inquiry somewhere, and this inquiry is sent across the internet. But with blockchain, we are able to send not only the information that we are going to send someone money, but we can actually send him money in a peer-to-peer way. And this value transfer is facilitated by blockchain. So therefore, blockchain is so hyped and many people believe in its potential because of this. Because transaction of value across internet can be facilitated by blockchain. We'll come to Internet of Values. You may think like, okay, so what, like we are using banks and we are happy with banks. But as mentioned, like 2 billion of people in the world are unbanked. Well, currently it's like 1.7 billion. So here in developed countries, we don't feel actual need of for a better value transfer. But think of a very simple use case as invoicing. Invoicing in 1970s, no need to go into detail, but basically what was happening, someone wrote an invoice, they sent it across the standard postal service to someone, and the invoice was paid. With the rise of internet, nothing basically changed. In very essence, it remained the same, but we are not using standard postal services for sending invoice, but we are using emails. And we are creating all those fancy PDF layouts with invoices, and we are sending invoices across email, and then we are waiting for the payment. This might not sound as an issue, but in very essence, every settlement time in global supply chains, due to this inefficiency, is 52 days. So it means someone is waiting for someone to pay them for 52 days. Needless to say that producers who are at the beginning of the supply chains are waiting sometimes for 3 months. So for 3 months they are basically stuck somewhere, not able to do the resource planning properly, not able to do forecast properly, because they are waiting for the payment which they are never sure if they are going to receive. Whereas end of supply chain, so us, when we go to grocery store, we pay something, the settlement is almost instant. Yes, there are some details, but yes, we perceive this as an instant. So let's have a look at invoicing of tomorrow. Maybe no invoicing. I'm a bit exaggerating here. Obviously, invoicing is here to stay to some extent due to accounting and law and all the stuff around. But what if we can do the things differently with the blockchain? So let's have a look at a very basic supply chain. We have a producer who is producing apples. And this producer sends goods to supplier, and supplier scans the goods. And the payment, because of the blockchain-based solution behind, is transferred automatically. So the money is sent in a very second as supplier receives the goods and he scans the QR code. The same happens on the retail side. So when a retailer receives the goods from the supplier, he can scan it and the payment is transferred automatically. This kind of blockchain-based solution in a background can be facilitated by smart contracts and cryptocurrencies, and technically this is feasible on Ethereum blockchain. Are there any questions now? I can take one short question. Okay, I assume it's clear. If not, we'll have a session afterwards. Okay, let's wrap it up. What is a blockchain? Here I'll introduce some vocabulary because there are a lot of misconceptions around this space, and this is something what prevents from adoption and what prevents from many people to believe that blockchain has got the potential, because many people follow the price. Yes, now the price is low, the market crashed, many people sold everything, they got angry, they got upset, and they don't want to listen to word blockchain anymore. Why? Because they don't understand potentially what is the technology about and what can it bring us. So vocabulary, blockchain. For you as a takeaway is blockchain is immutable distributed ledger. No matter how complex it sounds, but this is the definition: immutable distributed ledger of transactions performed by the network participants. We'll explain later how this is facilitated. You may wonder, okay, blockchain, where is the chain and blocks? By the way, some joke. I went to one conference and there was a Bitcoin core developer, Peter Todd, and he was asked like, how can you simply describe what is a blockchain? And he was like, well, it's a chain of blocks. And it's very true. So here is the chain of blocks. In every block, we have transactions ever performed on blockchain piled up, and then the block is hashed. And then it contains also the reference to the previous block. So basically, block contains transactions piled up with the reference to the previous block. So this is how the chain, how the link is created. So this is the chain of blocks, so blockchain, very roughly speaking. I mentioned word distributed. For you to understand, there are, like, generally speaking, 3 kinds of network: centralized, decentralized, and distributed. So basically now even banks are somewhere here decentralized because they operate worldwide, and usually from legal perspective they have like different entities. But in the past they were pretty much centralized, so there was one headquarters sort of, and everything was governed from the center. But in case of blockchain, the preference is for a distributed network. Okay, another notion in a blockchain space is node. Node is basically a miner or any kind of participant in a network. Participant, it can be also you as an end user, so a person who has got bitcoins in their wallet and do some transactions. You don't have to be miner to be a node. Every node, every full node to be more precise, contains a ledger of transactions. So imagine in a Bitcoin blockchain, currently we have more than 10,000 nodes who are having entire database of all the transactions ever performed on Bitcoin blockchain. Currently, Bitcoin blockchain is like 190 gigabytes, something around that. So it's not a huge file, but for you as only end user having a wallet with Bitcoins, it would be super inconvenient if you would be supposed to download the 190 gigabytes and to do some operations on top of it. So therefore, and another notion before I jump into explanation what is node is a wallet. But many people mistakenly think that, okay, I have a wallet and it holds funds. It's not true. So basically we have a blockchain, well, let's say Bitcoin blockchain, and we have a wallet. And wallet is only interface which enables us to have a look how many Bitcoins do we have and to do transactions over those Bitcoins. Wallet is only user interface. It doesn't hold any funds. And another notion you might come across is permission and permissionless blockchains. It's a lot of politics in this space because enterprises and enterprise blockchains are usually permissioned, and Bitcoin or Ethereum blockchains are permissionless blockchains. What does it mean? Permission blockchain. In the Netherlands we have few working use cases, and they all run, just to put you in context, permission blockchain has 7 nodes. So basically 7 geographically distributed miners make sure that the blockchain is immutable. And it's up to those miners or up to governance of the blockchain who can access the network. Whereas in Bitcoin blockchain or Ethereum blockchain, so in permissionless case, it's like this, everyone can join. Everyone can become a miner, everyone can buy Ethereum, everyone can transact Ethereum. So this is the difference between those two worlds. But I really like comparison, and I think it's very true. It's pretty much like intranet in the past and internet now. So in the past, like big enterprises, they didn't go for internet straight away. First they were using some kind of closed networks, which were called intranets and other kinds. But the point I'm trying to make here that basically permission blockchains are seen by some professionals as only interim step to jump into permissionless blockchains. Because permission blockchain in very essence can be considered as an improved database. So you can facilitate pretty much what you can do with permission blockchain, you can facilitate with more advanced database. Okay, Ethereum fundamentals. Who of you have heard of Ethereum before? I assume like everyone. Yes, nice. Okay, to explain, blockchain is the hardware where where we have protocols. So in case of Ethereum, the protocol is called Ethereum. In case of Bitcoin, the protocol is called Bitcoin. And depends on what kind of protocol do we have. Sometimes it contains cryptocurrency and sometimes does not. So in case of Ethereum, we have like the hardware blockchain, and then Ethereum protocol sitting on top of that and ruling some governance there. And then we have cryptocurrency, which is called Ether. In case of Bitcoin, there is no distinction between Bitcoin protocol and Bitcoin as a cryptocurrency. Ethereum protocol, Ether, cryptocurrency. Just a few features. Ethereum is inflationary, so it doesn't have any hard cap as Bitcoin has. There will never ever be more than 21 million Bitcoins in the future, whereas with Ethereum is something which is now being discussed. It uses proof of work. Proof of work is a consensus mechanism. We won't go into details of consensus mechanism because it would be for an entire day. But I suggest you look into it. It's pretty fascinating how someone thought of this kind of consensus as proof of work as a mean to secure Bitcoin blockchain, or in this case Ethereum blockchain. Notable forks, we'll speak about Ethereum Classic, and you might have come across Notion apps, distributed apps. It's basically nothing else than some application sitting on top of Ethereum blockchain. Okay, outline, we'll have a look into development, upgrades, hacks. What kind of accounts do we find on Ethereum blockchain? How is communication between those accounts performed? And a bit of EVM. So development. The idea of Ethereum came up back in late 2013 by a guy called Vitalik Buterin, obviously Russian. He was working on Bitcoin previously, but then he wanted to suggest some improvements, and he didn't find any support base within the Bitcoin community. So he decided to fork off and to start creating something on his own. So he started in Switzerland early 2014. In July and August, they performed public crowd sale to get the money to pay developers to build up the entire ecosystem. And they raised back then like 50 million USD. And why the name Ethereum? No one knows. I mean, Vitalik claims that he just read Wikipedia about something and he just liked it. So, therefore the name. Upgrades. Upgrades are called sometimes forks, but there is a difference between hard fork and soft fork. What you see here can be considered as a soft fork. So, once we have blockchain out there and it's running on 10,000 nodes and we want to change something, it depends on the measure of the change. If we have to create a new blockchain, so it sustains like the change we want to have by itself, or if we are able to implement the current change into the existing blockchain. And basically how it works, the upgrade is proposed to the community. Community is then discussing like what are the benefits, what do we get out of it, is it technically feasible, and this kind of things. And then miners are basically those who are adopting the protocol. In Ethereum, we could witness already 4 upgrades, the latest one being a year ago. But the latest one brought us, besides many other things, very important feature, because I mentioned Ethereum is permissionless blockchain. But many of us might be like concerned about the privacy issues, because you don't want any data to be public when you are enterprise building on top of Ethereum permissionless blockchain. But with the latest upgrade of Ethereum, they integrated something which is called ZK snarks, and it has been inspired by another cryptocurrency called Zcash. For you to understand like what it's all about, I mean, ZK stands for zero knowledge, and here is the like zero knowledge, like what does it mean? So for you to understand like how this complex concept from cryptography works, let's have a look at the example. Imagine this is Ice Age and this is a cave, and there is a man and there is a woman. And the woman is being a bit not happy with her man, so she doesn't want to tell him like what is the password to open this door. Only she knows what is the password, but she doesn't want to tell him. And so he challenges her like, okay dear, if you know what the password is, you go inside and you return from the path A if you are right. Okay, so she goes inside and obviously she knows the password, so she opens this door and she's able to come back from the way he told her to come. Basically, when they iterate this for 1,000 times and she always proves right, he can be sure that, okay, she knows the password. because there is no other way how can she go about this challenge. So he's like confident, okay, she knows the password, but he still doesn't know what the password is. And this is the zero knowledge. So the prover proves to the verifier that, yes, I know, but you don't know. And the verifier is like, okay, so you know, but I don't know. So we agree that, yes, you have the secret you want to disclose. And this concept from cryptography is now being used in banking a lot. For instance, in the Netherlands, ING Bank, they developed something which is called zero knowledge range proof. It's basically upgrade of Ethereum. And what is surprising, they made it open source as a bank. And now they are sitting in a discussion at one table with Ethereum Foundation, with Consensus, and with other key people from Ethereum community. And they are using zero knowledge proof. They are having like 45 blockchain use cases within their ecosystem. And they are using zero knowledge proofs, for instance, to check, like when a bank is interested in giving you mortgage, and there is some data which is confidential even to them. So they are using the zero knowledge proof approach to find out, okay, if you lie between some thresholds, and hence you are eligible for a mortgage. And yes, very important to say that every fork and every successful upgrade of blockchain is a reason to celebrate. Because it's not an easy thing when you have to deploy something for 10,000 nodes in the world, and to make sure that the history of the blockchain hasn't been changed, that miners can operate as they operated until now. And also there are lots of tiny things to think of, so I'm not very jealous of having this responsibility. Hacks. So the first hack, yes, here disclaimer, blockchain has never ever been hacked. So when you read somewhere in a newspaper, blockchain was hacked, Bitcoin was hacked, whatever, it's not true. What can be hacked are services around blockchain. So exchanges, wallets, and other custodian services and these kind of things. But blockchain itself has never ever been hacked. Also here what we call therefore hack is in a quotes. Because what we call here the hack was, in 2016, DAO is a distributed autonomous organization. It was basically a project which was supposed to run on the top of Ethereum. And they had idea, like now we have this hierarchy in every work, so we have a manager who is giving you tasks. And they had idea, okay, we have Ethereum, we have smart contracts, so let's make it more in a peer-to-peer way. So this was the idea, and they launched the public crowd sale, where they raised 150 million. Just so you know, the public crowd sale was in cryptocurrency in Ether, and governance around this public crowd sale was built on top of Ethereum. And what happened back then, someone managed to claim 50 million USD. So imagine that there was like some public crowd sale running, and there was some wallet, roughly speaking, with $150 million. And someone managed to hack the wallet. So everything was sort of like in line with what was feasible on top of Ethereum blockchain. But there was a huge political discussion in the Ethereum community. You see now the year 2016, so when we have a look back, the very first version of Ethereum was launched in May 2015. So like a year after, there was this major thing happening. So Ethereum community had a big discussion like, okay, what do we do? In case we revert the chain, so hence rewrite the history of blockchain and give the funds back, so not the anonymous entity has them, then yes, it might be a solution, but like Bitcoin community says, protocol is a protocol. We shall stick to it. What we deployed once and what is running now on a blockchain, we shall stick to it. But in Ethereum back then, due to the thing that they were pretty fresh in the market, they didn't want the Ethereum to decrease in the price. They decided to fork. So basically revert the chain. And since then, we have something which is called Ethereum Classic. It's the original version of Ethereum, and Ethereum as you might know it now. Okay, upcoming upgrades, Metropolis and Serenity. There is a discussion, as I mentioned, like about making Ethereum also deflationary instead of inflationary, and there is also discussion of changing the consensus. But this is not the subject of this presentation. Let's have a look at the accounts. Here we get a bit more technical. So accounts on Ethereum blockchain, they interact with each other through message passing network. There are two types of accounts, externally owned accounts and smart contract accounts. Let's have a look how it looks. Okay, so wallet is externally owned accounts. It means we have private keys and we can access the wallet, so therefore externally owned account. Then we have contract accounts. So it's some kind of script sitting on top of a blockchain, and it enables us to create conditional payments, for instance. Let's have a look how those two accounts can communicate. So between the wallets, we only can do a value transfer. Between a wallet and a contract account, we can basically use wallet to trigger some activity in a smart contract. But the contract itself, it cannot do anything by itself. Contract is waiting for a trigger from externally owned account. Okay, very important for you to take away as well is a notion Ethereum virtual machine. Ethereum virtual machine enables us basically to program smart contracts on top of a blockchain. So do you remember the case of a supply chain? So with Ethereum we are able to create the conditional payments. So if the QR code is scanned, then the payment is sent, roughly speaking. And if it's not scanned, or if it's wrong, or if something goes wrong, then we can have also else. So if then else, Ethereum virtual machine, you can program smart contracts in a language called Solidity. It's very similar to JavaScript, and it's semi-Turing complete because the looping is prevented by gas. We'll talk about gas later. So every account has 4 components. I will just run quickly through it. I will share slides with you later. So nonce, balance, storage, root, and code hash. Then we have, so this was account state. So every wallet, externally owned account, and every smart contract has a state. But then we also have something which is called world state, and this is basically a state of entire Ethereum blockchain. A very important notion are Merkle trees. I'm not sure how many of you are familiar with Merkle trees, but this is very important in entire blockchain space. And very important, Merkle is not Merkle. Because, you know, I've been attending a lot of conferences, I've been listening to top professionals in the world, and whenever I see this typo, this is my face as well, you know, like. Anyways, Merkle trees. This is how Merkle tree looks like in Ethereum blockchain. I mean, for now, it's not very important for you to remember, like, what precisely is there, but just so you understand, Merkle tree is actually like a tree, and it starts with one hash, and then it breaks down to many. And then there is a data, so actual transactions and entire data on the blockchain. And why this structure is important is because of the Merkle proof. So imagine having a Bitcoin blockchain of 190 or whatever, 200 gigabytes now. If you would be to check if every transaction is verified and is in blockchain, and if you would be to run and to compare it with 200 gigabytes of data each and every time, it will be highly cost and time inefficient. So basically with Merkle trees and with this structure, whereas the data about transactions is lying somewhere underneath, you can take like a precise transaction from a block. Now I'm talking very high level. But what is sufficient, we have like small piece of data from entire blockchain. So let's say like in Bitcoin it's 200 gigabytes. And let's assume that I want to verify if 2 kilobytes are actually there. So I hash them, and then for me it's only sufficient to know like the green hash is here. up to the top of the tree of the Merkle, just to be sure that yes, these 5 or 2, whatever kilobytes of the data I'm having now, and I want to prove that they are in a Bitcoin blockchain, actually come from a Bitcoin blockchain. And this is how Merkle trees look like in Ethereum. So you see it's pretty complex. But I mean, yeah, this complexity is done because we want to make some efficiency in the end, right? So actually, like here, what you see, those are hashes. So strings, 64 characters, digits 0 to 9, letters A to F. But the actual data of transactions, so who sent to whom, how many Ethereum in the past, or what is the smart contract about, or these kind of things, they are somewhere below it. And therefore, due to this feature, I make this implemented in many blockchains, not all. Due to this feature, we are able to create wallets. So, how it's possible that you can have a Bitcoin wallet in your phone without having entire Bitcoin blockchain in your phone? Because of this. Because your phone is only able to validate due to Merkle trees that, okay, I'm like accessing the correct blockchain and I'm now validating transactions. You don't have to have 200 gigabytes of Bitcoin blockchain in your phone to have a wallet. I mentioned nodes, so full nodes is a miner or anyone who downloads now Bitcoin blockchain 200 gigabytes, and the light node is a wallet, for instance. As I just mentioned, you have some wallet in your phone, and you are automatically a light node. To reiterate, node is any participant in the network. It doesn't have to be miner, it can be a person only having a wallet in their phone. Why it's so important? Why I'm so mentioning this? Because of the number of the nodes in a blockchain, we are able to evaluate like what is the potential for 51% attack. Like as I mentioned, permission blockchains, when they run on 7 nodes, when you don't go well about the governance of those 7 nodes, and you store them like in one room and you tell one person, okay, you go and run it, then obviously the person, when they are prone to do some fraud or scam, they will do it, because like everything is there. It's very easy for them to take the network over when it's so small and geographically concentrated. But when you have Bitcoin blockchain, you have 10,000 nodes, even more now, geographically distributed, and they don't share one owner. In Ethereum, very important concept, they are gas and fees. So in Ethereum, everything is paid. So when you want to send Ether to someone, you have to pay. When you want to deploy a smart contract, you have to pay. And this payment in Ethereum context is called gas. Gas is only a unit, but the price for the gas is var. Just so you know. So every transaction has a gas limit and gas price. So for instance, it depends on the world state of the network, on the world state of Ethereum blockchain, how much are you going to pay for a transaction? So like last winter, we saw transactions were like, I think it was like $10 or something. I can't remember well. In Bitcoin blockchain, it was definitely $50 per transaction, but currently it's lower. So here for you to take away, on the public blockchains, the challenge is how to go about transaction fees so they sustain. Because when the network is congested, the transaction fees can get pretty high. And hence, for the end user, it's a disincentive to send someone cryptocurrency worth $2 when they have to pay $30 for transaction fee. And yes, important. In case the sender doesn't have enough gas, transaction doesn't go through. This is called atomicity of blockchain, like atomic feature of blockchain. So only transaction which is paid for and which is validated goes through. And obviously, the higher the gas price, the more likely are miners to process it. Why this? Think of you being a miner, investing in the hardware, and you want to make some return investment, obviously, So you won't be like taking any kind of transactions you would be targeting transactions with the highest fees. Because fee then goes to the miner, so to the person who processes the fees. Here, in case some of you are advanced in this topic, disclaimer, I'm keeping this high level. So it's more complex with fees than I'm talking now about. But for you to remember, fee goes to miner. Because it's used to pay the storage use as well. So when you have a smart contract talking about, okay, if goods are here, then do this, and then do that, and then do everything, and the code is like super long, and you want to deploy it on blockchain, and you pay not only like for the code itself, but also for the complexity. So when you introduce like multiplication instead of addition, you pay more. Well, depends on the context, but you have to pay for every single operation in a code. Very important notion. Yes, question.
Who pays the gas? Is the sender account or this contract account?
Gas. Gas is always with an externally owned account. Because the contract account is only like some script sitting on top of blockchain, but also the contract was deployed through the wallet, so through externally owned account, and now it only sits there, and it's waiting for some trigger from outside. And the wallet, externally owned account, is the entity within the blockchain, which is having an access to the funds to pay for the gas, for the contract deployment, for triggering some action with the contract, or for sending the funds from wallet to wallet. A very important notion in the blockchain space entirely are incentives. You may wonder, like, what is incentive and why it's so important? Blockchain brought us tokenomics. At the beginning, I was mentioning that I'm a consultant and my focus are token economic models. So tokenomics, roughly speaking, token economic models or token valuation is a set of rules within ecosystem which incentivize key players to contribute to the prosperity of the system. So when you think of a Bitcoin blockchain, you have miners, and you have people using the wallet only for transactions. So incentive for the miners to run the network is the mining reward. So they know when they buy some hardware now, there is a high probability that they will make some return on investment in the end. And when you think of incentives, they differ per ecosystem. So in Bitcoin ecosystem, the incentives are more complex than the Ethereum ecosystem. I mentioned in Ethereum you have to pay for everything. So for developers, the first incentive is to create as efficient code as possible. Because when you write your code on 400 lines, whereas it can be written on 150 lines, and you introduce more complexity into it, you know that you have to pay for it then. So you always strive for the efficiency of the code, so you pay less. And those are only tiny incentives I'm listing here, but when you think of any other ecosystem, we can think of, let's say, Uber. You can think okay, let's forget that there is some Uber company, let's make it distributed. And let's think of players in the ecosystem, so you have drivers and users, and maybe some more. And then you can break it down to what is the incentive of every participant to run the network so the network sustains. And you can come up with some solution, and then you can think of maybe a blockchain solution. It's far more complex than this one, but just so you understand, due to the ability to transfer small amounts of value with a certain liquidity at almost zero fees, we are able to completely transform some business models. And the latter is another thing which makes blockchains and cryptocurrencies so interesting. Okay, back to Ethereum. I was talking about blocks. All transactions are stored in a block. So as mentioned at the beginning, chain of blocks, blockchain. So in every block you have transactions piled up, and then the block is hashed, and it contains the reference to the previous block. So when someone tries to tamper the data in the previous block, so in the past, then the reference changes, and hence the entire network is alerted that, okay, this block was tried to be tampered. So in the blocks, besides transactions, we have header. Header is the Merkle tree thing you saw previously. And you have something which is called Omer. Omers are, I think, well, I'm not sure if this is not like too complex to close it with 2 sentences, but I will try. So when miners are mining blocks, and they are geographically distributed, due to latency of the network, it happens very often that like 2 miners in the world, they mine like blocks which are not equal, but which are very similar, and which contain validated transactions. So how do you go about this? Because imagine like you have a blockchain, so block, and all of a sudden there are 2 miners in the world who, due to latency, mine block, like which is recognized as a network as a valid block, but then all of a sudden like 2 blocks instead of 1 to continue the chain. So how do you go about this? These blocks are called Omers. And yes, I'm talking about like mining Ethereum, but basically what is happening, we are mining a block on Ethereum blockchain. So miners are those who are like creating those blocks of transactions and who are appending them to the chain of blocks. And this is how blockchain is created. So, as mentioned, the shorter the time of transactions, the more competing and often blocks we have. So in case of Ethereum, as mentioned, it's very common to have like blockchain, like chain of blocks, and all of a sudden 2 blocks which are recognized by a network as valid, but there are 2, so which chain do you go then? How do you continue? So in Ethereum, we have something which is called host protocol. Host is abbreviation, it stands for greedy habits of subtree. And basically, we let the miners to continue in both of the chains, and then we evaluate which chain needed to use more computational power. And then the other branch is discarded, and then we go only for the longer branch. So we pick the part that has the most computation power done on it. Okay, this is a block header. This is something what you saw on the few slides ago. But I would suggest that it's not important for you to remember all the list of items in the block header of Ethereum blockchain. But for you as a takeaway, let's close it off on a very general note, because I think in the blockchain space there are a lot of misconceptions, a lot of fraud, a lot of scam, and there is a lot to be done to fix the perception of cryptocurrencies in the world. But for you, as a takeaway, as mentioned, you can forget what's in Ethereum block header, but remember the 5 things I'm going to list now. So, when you enter blockchain space, you have to accept that you shall never stop studying. There are sometimes major updates every week. Depends on which ecosystem you follow. Currently, there are more than 1,500 cryptocurrencies, and each of them has specifics. Obviously, you can discard like, okay, I said 1,500, you can discard like 1,450. But 1,450. But studying and doing your own research is very crucial in this space. What is very important and what many people don't like to follow is don't buy just because it seems to skyrocket soon. I mean, it's not the case now, but who knows, maybe in 2 months it will change. But always before you buy, have a look at if cryptocurrency has these features, because every cryptocurrency invested scenario is a strong community. Imagine, it's like, it's comparable to Linux. Linux is open source software and it has good community and it has similar features to Ethereum ecosystem, for instance. So when someone tries to develop permissionless blockchain and you have a look at their team and there are 3 people sitting, they're not going to sustain. Where is the community? Where are the people who are going to come up with a roadmap, who are going to come up with upgrades in the future? Then, yes, there is a code. I think like every cryptocurrency now shall have some code. However, some are only website and there is nothing in the backend. Every cryptocurrency also is a blockchain. But here for you to understand also, I was mentioning blockchain, Ethereum as a protocol, Ether as a cryptocurrency, but also applications on top of Ethereum, like those smart contract things, smart contract scripts, can be considered in some cases as a cryptocurrency. Every cryptocurrency should potentially have some purpose. This is pretty political, but some cryptocurrencies, they don't have a clear idea like why were they created. I mean, the community behind. They were just playing around and they come up with this thing like Dogecoin or whatever. Then every cryptocurrency is preferably value. It means a product. Also, there shall be some traction. So as mentioned, the community shall be clear on what is the roadmap they have to deliver, because this is how we can earn confidence that this cryptocurrency is going to sustain. And obviously, network effect is very important. So as I mentioned, now Bitcoin blockchain 10,000 nodes, Ethereum, I don't know how many, like 5,000 something. But when you have a cryptocurrency which is run by 100 people in the world, how are you going to make sure that it's secure now, that it works in 20 years and these kind of things? Because in very essence, buying is voting. So when you buy, you support. And there are many cryptocurrencies which are heavily pre-mined. It means there was an idea to create a cryptocurrency. So someone created, let's say, 100 million cryptocurrencies, and they took for themselves 90 million. They made some great marketing, and they let 10 million into market, and they were like, okay, let's have a look at the craze now, They pump up the price, and people went like crazy for the 10% of the supply. And by playing in the market, by pumping down, then they were able to increase the stocks of the pre-mine sometimes by 50%. So imagine how sick this is. So someone who is rich enough, they used the hype and they created this kind of concept that, okay, here's the cryptocurrency, I keep 90% for myself, and you guys, you go and play and let's see what happens. So therefore, we always say buying equals voting. And in open source and cryptocurrency space, even more. Okay, because, maybe it's only my personal opinion, but in this free market, it's up to us, up to end consumers, who will sort of vote, so who will buy. And we are those who can determine, who can shape the future of the cryptocurrency space. And I like this picture. Because many people are objecting that, okay, Bitcoin is a religion and it's only a matter of belief. But how does it differ from fiat currencies in very essence? As we can have a long discussion on this, but there are many things only about belief in the world. And regulation is a very big thing in the blockchain space, because regulators, they are doing like in China, they completely banned Bitcoin like a year ago. Now they yes, you can buy some Bitcoin there. Here in Europe, we are like pretty indifferent, yes, like these cryptocurrencies, ICOs, but regulators, they just don't know what to do. And in the US, it's heavily regulated. So there is a need for finding a balance between regulation and innovation. Regulation can become a bottleneck for innovation when not done correctly. So blockchain is an innovation and flying car is an innovation. So you may wonder, what is the difference? But the thing with flying car, and this is a true story, I was speaking to engineers, and imagine you are really building such a flying car, and you want to have it fully regulated in order to be able to sell it commercially. So you approach the regulators, and they have regulation for planes and for cars. They take the regulation, they merge it, they tweak it, and they will come up with a long checklist of features of your flying car you have to comply to in order to have your flying car fully regulated in some continents. This is a true story. I was surprised because somehow will make any sense to me. But because when I think of cryptocurrency space, when you approach regulators and you tell them, guys, here is my exchange, I've got a total volume of $100 billion, and I'm ready to enable people to trade cryptocurrencies. And regulators, they'll be like, wow, first, which jurisdiction, where is the exchange, what is the total volume, how do you do KYC AML, how much is the amount maximum people can cash out per day, and all these kind of things, and they are not set. And even in Europe, we have big differences, because for instance, in Slovakia, the country where I'm from, the regulators are approaching cryptocurrencies as virtual currencies. So they have vending machines, gaming machines in casinos. You have there some points. And they took the regulation from this environment and they're applying it now to cryptocurrencies. It's not only in Slovakia, it's in many other countries. Because it's easier to take existing regulation, which seems like, this is the same thing. Whereas in the US, there is a discussion, is Bitcoin a commodity? Is it security? Is what is it, No one knows. With blockchain, we have an entire dictionary of terms average people don't understand. So this is not a typo, BUIDL. It comes from HODL, which is not a typo either. But BUIDL means like building for a long term. So for takeaway for you to be support BUIDLing. So when you see some solid blockchain project, and if you are an investor yourself, be very critical on the points I listed previously, but be open to support them. Because due to this perception of investors that, like Bitcoin, Ethereum, Merkle, whatever, they are all the same, they are cryptocurrency, they are all scam. Due to this major general perception, many very good projects are hurt in the background. There are a lot of projects who are helping to microfinance emerging economies. And they are really achieving a lot. They are really improving the lives of the people in emerging economies, no matter how pathetic I sound now, but it's true. I saw those projects and it's incredible what can be done with blockchain as a means of peer-to-peer transfer value. And enjoy crypto humor, because I'm not sure if you follow, but there is this regulation by European Union. They banned these kind of pictures. So, you can still find them, obviously, but officially, the ISPs or whoever, I don't know, maybe creator, they shall be punished for us having fun. And thank you.